important topic. See, this is not only now for 12th standard everywhere. Every dimensions means physics and dimensions are very inseparable. Everywhere, every field you will have to apply. Okay. So what is now? We'll go to that. Dimensions of a physical, very important topic. That's all I can say. Okay, all of you, just give your full concentration here. Dimensions of a physical quantity. Now we are going to enter, see, dimensional analysis. Dimensional analysis. Okay, there. What is it? Just to start, what is the dimension of a physical quantity? What do you mean by dimension of a physical quantity? See, already we have seen that there are in SI system, no, there are 7 fundamental physical quantities and base physical quantities are there in SI system. Okay, and those physical quantities are actually called as 7 dimensions of physical world because they are base quantities. Okay, they are base quantities. So what are base or fundamental physical quantities, and they are called as 7 dimensions of physical world. I think you know what are all the base quantities just from for what is a mass. Okay, base quantities means first it is mass. So how to represent? See, the dimension for mass. It is, I told you, all these 7 quantities are called as 7 dimensions of physical world. So how to represent mass in the dimension form? Okay, therefore, what is a dimension? You can say, what is a dimension for mass, or what is a dimensional formula for mass? If I want, I have to give, see, that should be, everything will be represented M within the bracket like this. You have to write M. This is the dimension for mass. Okay, unit for mass is kilogram, SI unit. But dimension, as I told you, it is dimension for mass is M. Okay, therefore, dimension for length. Length means dimension is L for length. Okay, but unit, SI unit is meter. Okay, then dimension for time. Okay, dimension for time is T. Okay, I told you all the SI, so in the SI system, we have 7 fundamental physical quantities and units. Okay, all these quantities are called as 7 dimensions of physical world. Therefore, how to represent the dimension? Mass is one of the dimension of physical world, very important dimension in mechanics, that too. Therefore, mass, length and time. How to represent the dimension of mass? M within the bracket like that. Okay. Therefore, like that, let me see what is that next one? Electric current. Electric current. How to represent? What is the dimension? Dimension of electric current is A. Okay. Unit is ampere within the bracket. Okay. Right. First, to start with, we will use all the brackets. After that, you will know what to do. Okay. Then, next one is temperature. Temperature, what is the dimension for that? It is K, capital K. Kelvin is a unit and a dimension. Then, luminous intensity. Luminous intensity is, you know, candela. How to represent this? Capital C like that. This is the dimension. Then amount of substance. Amount of substance, it is mole, the same thing. Dimension also, what is that? Same thing, mole. Okay, so these are all the 7 dimensions of physical world, basic physical quantity, and they are called as 7 dimensions of physical world. Everything. How to represent dimension of mass means within the bracket, capital M means it is a dimension of mass like that. Okay, right. So, but okay, we're fine. we have given the dimension for all the fundamental physical quantities. Okay. But how to give the dimensions of derived physical, any randomly I take any physical quantity. Okay. So how to give the dimension? Therefore, how to the dimension of any physical quantity, okay, any derived, you can say, any physical quantity are nothing but the powers to which the unit of the fundamental physical quantity ought to be raised to represent the unit of the derived physical quantity. Once again, what is a dimension? The dimensions of a physical quantity, dimension of any physical quantity, okay, yes, nothing but the powers to which the units of the fundamental physical quantities ought to be raised to represent the unit of the derived physical quantity. Okay, what is it, how to represent? Therefore, see, can you give any simple physical quantity, derived physical quantity? Can anyone? We will see.
Ma'am,
Huh?
ma'am, can you please repeat the definition again, ma'am?
Yeah, these are all the these are all the fundamental physical quantities for which I have given the they are called 7 dimensions of the physical world. Okay, now I want to give the dimension the same like this. I want to give the dimension for any other physical quantity, derived physical quantity. So what to do? The dimensions of any physical quantity, okay, is nothing but the powers to which the units of the fundamental quantities are raised to represent the derived unit of that quantity. Once again, the dimension of any physical quantity, okay, yes, the powers is nothing. What is that? It is the powers to which the units of the fundamental or base physical quantities to be raised in order to represent the unit of which unit? Derived unit of that physical quantity. Hope you are following. I will give you the example, then I think you will understand. Okay, so what is that? Now, can you give me any derived, very, very simple derived unit? We will start from that.
Speed.
Yeah?
Speed.
Okay, speed. Okay, before that, speed means 2 things are required. Let me have only one because we'll start with the simplest one. Area. Okay, speed we will do, but first, area depends on what is area. Can you tell me? Area is nothing but, okay, if it is a square means length into length. If it is a rectangle means length into breadth. Breadth is nothing which physical quantity. Once again, it is nothing but length, breadth, height, everything, and everything comes under the base quantity. What is called length. It is nothing but length. Correct? Therefore, area means there are 2 things required. What is that? Length and breadth. Correct? Length and breadth. Okay. Now I want to give the dimension. Therefore, how to give dimension? Dimension of area is nothing but length. Length, what is the dimension? L. Correct? Into what is the dimension for breadth?
L.
L. That's it. Is it clear? L. That is it. Therefore, what is the net dimension of what is the dimension of area? L square. It is, that is why I told you the physical, for example, after that I'll come back to the definition. Okay, volume, dimension of volume. I am going from simplest case, which depends only on one base quantity. Okay, volume. Volume means what is that? Length into breadth into height, correct? Sir? Into height. Therefore, length into breadth, if there is a cube, okay, if there is a cube, what is the volume of the cube is length into breadth into height. Okay. Therefore, what is the dimension of volume? Dimension of volume is nothing but, okay, a dimension or dimensional formula also you can say. Sometimes you can say dimension or dimensional formula. Okay, formula for what? Volume. Okay, for volume that is equal to for volume whatever is that? That is equal to L. Okay, L breadth once again L, height once again L. Everything comes under the same physical quantity. Therefore, you can say it is L cube. Okay, right. Now you come to speed. Okay, speed. Therefore, dimensional formula for speed. Speed is nothing but, you can say it is displacement distance by time. Correct? Speed or velocity means displacement by time. I think you have idea. What is the difference between speed and velocity? Can you tell me? What is the main difference between speed and velocity? What is the difference?
Speed is distance by time taken and velocity is displacement by time taken.
That's it. Okay. Speed being a scalar quantity which has only magnitude. But the velocity means it is a vector quantity which has both the magnitude as well as direction. Velocity means what is that? A car is moving with a velocity of 100 kilometer per hour due north. In which direction? Also you have to tell. Speed means just like that. What is the speed? That is enough. There is no need to give you any direction. Therefore, anyhow, it is vector and the scale speed that is equal to distance by time. And what is the dimension for distance? Therefore, what is the dimension for distance?
Length.
Displacement, whatever it is, L. And what is the dimension for time? T. Correct? Therefore, how to represent? That is nothing but dimension of speed or velocity. Both are same. Distance or displacement. Both come under the physical quantity L. Correct? Therefore, whether it is a speed or it is a velocity, the dimension is same. Okay, dimension is the same. Therefore, what is that here? L. Therefore, if I put both together, L T power, this is nothing. Okay, let me write L and T power minus 1. Correct? T power, therefore, it is L T power minus 1. This is the dimension or dimensional formula for what is that? Speed. But one time, if in mechanics, whether it depends on mass, speed depends on mass. Whether speed is depending on mass? Children?
No, ma'am.
No. Okay. Therefore, I can emphasize that. Okay, here L T power minus 1. Because I can emphasize that in mechanics, what are all the three fundamental quantities? M, mass, length, and time. So, therefore, in that case, if I want to, of course, you know very well here other things. What is that? Electricity, ampere, candela, Kelvin. Everything it is not immaterial here for this. Therefore, speed depends. I want to represent that dimensional formula. If I want to write what is a complete representation, dimensional formula for speed. if I want to write, I can write like this also. What is that? M, it is independent of M, na? M power 0 kar sakte hain. Okay, and L, how it depends? L power 1. Correct? L power 1 and T power minus 1. Hope you are following, both are same only. Correct? Both are same. L means L power 1 only now. M power 0. M power 0 is nothing but something. Power 0 is?
1.
1.
Okay, so it is not going to matter. The M power 0, L power 1, T power minus 1 is the complete representation of dimensional formula for speed. Okay, right. Now you come back to your dimension of any derived physical quantity is the powers to which the fundamental physical quantity ought to be raised to represent.
Ma'am, density.
Yes, to represent the derived unit of the physical quantity. How? Here speed means meter per second. Correct? Unit क्या होता है speed का? What is the unit for speed? Unit of speed. Meter per second. Therefore, meter means L. Meter means meter power 1. Okay. Therefore, meter means length. What is the dimension for length? L. Therefore, L power 1. Here, time unit is second. But what is the dimension? T. Therefore, T power minus 1. Are you following? If you know the unit, from that you can give the dimension also directly. Okay. Why? Because on what factors? Any physical quantity, if I want to give the dimensional formula of any physical quantity, okay, it gives you an idea on what factors, what are all the base physical quantities, it depends. Okay, what are all the base physical quantity on which it depends. Here, if I want to give the dimension for speed, the base physical quantity on which it depends is only length and time. Okay, so how it depends? It depends on base physical length and time. How it depends? That is given by the powers. Okay, therefore 1 dimension of length minus 1 dimension of time. It depends on 1 dimension of length. How it is represented? 1 dimension of length and minus 1 dimension of what is that? Time. Okay, like that. Are you following, children? Whether it is clear? You have
yes, ma'am.
Okay, therefore, now, if I want to get, therefore, this is dimensional formula. Okay, if I want to give a dimensional equation. It is a dimensional formula. Dimensional formula means you have to write like this. Okay, let me give you something else. Dimensional formula. Dimensional formula for density. Density, that is nothing. But what is density? Mass by density. Volume. Mass by volume. What is the unit for mass? Dimension for mass? M. Correct?
M.
Okay. What is the dimension for volume?
L cube.
Oh. Okay. If I want to write, it is M and L power minus 3. Following? So that is, I am coming very, very basic thing. It is okay. Therefore, it is M. If I want to represent M power 1, correct? And L, whether L power minus 3. Okay. T power
0.
That is it. Okay, so this is the dimensional formula for density. Right. Now let us go to, okay, anyhow, we will be seeing dimensional formula for so many physical quantities now. Anyhow, before that, let me give you one thing. What is a dimensional equation? Now, because after that, we'll go for dimensional equation. Very simple. It is given some different names, that's all. Okay, dimensional equations. See, You know, just now we have seen dimensional formula for velocity, you know, no? Dimensional formula for velocity is, what is that? L t power minus m power 0, L power 1, t power minus 1. But I want to represent the dimensional formula in terms of dimensional equation. Equation when I give the LHS, RHS hona chahiye na? Equation, that is got to be equation. Therefore, how to give the same dimensional formula for speed in terms of equation? I can write like that. See, dimensional equation for speed or velocity is given by, if I want to write in terms of LHS, RHS, I have to write like this. How? It is m power 0, L power 1, t power minus 1. That's all. This is a dimensional equation. Are you following? What is the difference between dimensional formula and dimensional equation? Dimensional formula for velocity is given by m power 0, L power 1, t power minus 1. But if I want to represent in terms of equation, that should be LHS and RHS. Equation means that should be LHS, RHS. How to? Therefore, here it is a dimensional equation. How it is for what? Velocity. It represents this m power 0, L power 1, t power minus 1 represents only velocity. Therefore, you keep that one in the left hand side. Yeah, V within the bracket. Okay, that is nothing at m power 0, L power 1, t power minus 2. Okay, is it clear? Understood?
Yes, ma'am.
Yes, ma'am.
Yes,
Now,
ma'am.
I will ask you now, what is the dimensional formula for momentum, linear momentum? What is linear
Mass
momentum?
into velocity.
Linear momentum. How to represent linear momentum usually?
P, ma'am.
Small p. Correct? Linear momentum. That is mass into velocity. Okay. Therefore, P. Dimensional formula for P is m. First mass m. And velocity, you know that. Tell me. M power 0, L power 1, t power minus 1. Correct? Therefore, if I write this here, what is for momentum, if I combine everything, I'll be getting m power 1, L power 1, t power minus 1. Okay, so this is for momentum, m power 1, L power 1, t power minus 1. Therefore, if from this you can even directly give the unit also. How? See, unit and dimension. If you know the dimension, you can give the unit. If you give the unit, if you are given the unit, you can, from that you can find out the dimension. How? See, mass, kilogram. Correct? Length, unit, meter. Okay, per second. Therefore, S power minus 1. Kilogram meter per second is nothing but unit for momentum, linear momentum. Therefore, how to represent in the equation? How to same can be represented in the equation from dimensional equation? Same thing, very simple. M power 1, L power 1, t power minus 1. That's it. Hope you are able to follow.
Yes, ma'am.
Yes, ma'am.
Now let me give you, see, physical quantity. Let me tabulate and you have to tell me physical quantity. Randomly I am giving. Okay. And let me give you formula, so that from the formula you have to give the dimension. Okay. So dimensional formula. Of course, if you want, you can give the unit also. Okay. So tell me physical quantity. Let me give you one by one and let me see whether you are able to do it. Okay. Acceleration. What is acceleration? Formula kya hai? Acceleration.
Meter per second square.
Formula.
V minus u by t.
Change in velocity divided by time. Correct? V minus u by t. That is nothing but acceleration. Very good. Therefore, V minus u is nothing but only velocity, na? Velocity. Okay, V minus u is also nothing but is a velocity divided by change in velocity divided by time. Therefore, What is the numerator? Change velocity. Velocity means what is dimension formula? L
Length.
m power 0 L power 1 t power minus 1 divided by क्या है time t. Are you following? And that is nothing but m power 0 L power 1 t power t. If it comes to numerator minus 1, therefore you will be getting 10 power minus 2, t power minus 2. And formula right here. Are you following? Clear? Acceleration.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
See, then force. What is the formula for force? F is equal
Mass
to,
into acceleration.
yeah. So if you know the formula, from that easily you can find out the dimension now. Very simple. Okay. Therefore, now you tell me what is mass? M. M. Yeah. Just now we have seen M.
M0 L1 T minus 2.
Yeah, m power 0, L1 t power minus 2. Therefore, what will be your formula for dimensional formula for force will be m. Okay, m power 1, L power 1, t power minus 2. Got it? Got it?
Yes, ma'am.
Okay.
Yes, ma'am.
Let me give you. Who will give me the answer? Pressure. Gayatri is here. Gayatri. What is the formula for Gayatri? Are you here? How many are there? Total. See the number.
45.
45. 45 means 3 are absent. Okay. Gayatri is here. Gayatri, are you here?
Yes, ma'am. She is present.
She is present. Then why is she keeping quiet? See, this is not the way. Otherwise, if you don't know means you don't know, you tell. I cannot wait like this. Okay. Right, Kalpana. Kalpana.
Yes, ma'am.
Tell me, Kalpana.
Ma'am, SI unit.
Formula for pressure, ma.
F divided by A.
Force per unit area. Force per unit area. Therefore, dimensional formula force. Now just now we have seen. That is why I am what is required in the previous case. It is there. Readily you can. Therefore, it is m force के लिए तो m power 1 L power 1 t power minus 2 divided by area. Area
L
unit.
square.
L square.
Dimension is L square. Therefore, you will be getting this one m power 1. L power 1, L squared means it will become L power 1.
L power minus 1.
The denominator L power 1. Therefore, if it comes numerator L power minus 1. Are you following? Therefore, and t power minus 2. This is for pressure. M power 1, L power minus 1, t power minus 2. Is it clear? Then, next, what is the work done? Tell me, what is the formula for work done?
Force into distance.
Force into displacement. Okay, therefore, work done that is equal to F into S. Okay, therefore, F into S. Therefore, what is, tell me, force is known here now. M power 1, L power 1, T power minus 2, and S, distance. Therefore, length. Therefore, it is M power 1, L squared, T power minus 2. Hope you are following?
Yes, ma'am.
And whether energy, what
Yes,
is
ma'am.
work done? I think work done and energy are same. Correct? For, I think you have idea. Whatever work done, for example, okay, I will show you to you now. Any energy you do, kinetic
Madam,
energy.
sorry to cut in, madam. I'm Gandhi. I'm visiting all the classes. Good morning to all of you.
Yes, teacher.
Good morning, sir.
Thank you very much.
Good
Just
morning.
I'm visiting. Good morning, sir.
Good morning, sir.
Wish you all have a wonderful day. Thank you.
Thank you, sir. Thank you, sir.
Thank you very much.
Yeah. Let us go for kinetic energy. Kinetic energy. What is kinetic energy formula?
Half mv square.
Half mv square. Whether it is recording is going on? Children?
Yes, ma'am.
Yes, ma'am.
Okay. Therefore, half mv squared. Okay. Here, that numeral number is there, no? Half. That for dimension, it is irrelevant. It is irrelevant. We don't bother about that. It is a constant. Though constant will not have any dimension. Therefore, apart from constant, what is a mv squared? Hai na? So that you use. What is that? M. Mass. M power 1. V. What is V? L.
LT.
L. T power? L power 1, T power minus 1, na? M power 0, of course. I think now you know, no, M power 0, it is not that, there is no need. We will write L power 1, T power minus 1. Are you following? Are you following?
Yes, ma'am.
The whole square. V square. Okay. Therefore, now you tell me, what is that? M power 1, L
Same
square,
as work
L
done, ma'am.
square.
T power minus 2. Okay. Therefore, can you compare work done and energy?
Yes, ma'am.
Same, na? M L square T power minus 2. Therefore, work done only appears as energy. So, work done and energy both are having, even if you any energy, mgh. Okay, I will show it to you because it's important now. You should have an idea. Potential energy. Tell me. Potential energy formula क्या होता है? Gravitational potential energy करिए.
mgh.
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 That's it. mgh. G क्या? What is G, ma?
Force.
G
Force, ma'am. Gravitation.
Gravitation.
Acceleration due to gravity.
Acceleration due to gravity. G is acceleration due to gravity. That is nothing but acceleration. You're getting acceleration because of gravity. That is acceleration due to gravity. Okay. Therefore, mgh. M, capital M. G, acceleration. Now, what is for acceleration? Dimension L power 1. One of you tell me.
T power minus 2.
T power minus 2.
And H?
L.
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 Now consolidate now. What is that? M power 1. L. L squared. T power?
Minus 2.
Minus 2.
All are same, na? See?
Yes, ma'am.
And whatever is the form of energy, the dimension will be the same. Is it clear?
Yes,
Now,
ma'am.
Yes, ma'am.
power. What is power? Formula.
Rate of doing.
Work by time.
Work by time.
Work done by time. Rate of doing work is power. Okay. Therefore, how fastly you are doing work. If what is the power of? How do you compare the power of scooty and power of bike? Whose power is more?
Bike.
Why? Why? Actually, see the
More
word
horsepower, ma'am.
done per second.
Ma'am, CC.
Yeah, therefore,
Ma'am, CC, ma'am.
yeah, that is given by the power of an engine. Okay, power, it depends very much on the power of the engine. Therefore, power here, it is how fastly the work is done. That work done is okay. How fastly you are able to do work. Capacity, that is rate to which the work is done is what is called power. Okay, therefore, how to find work done? What is the formula for work done?
M1 L square T
Power minus 2.
and divided by time. Correct? Okay, therefore, what is that? M power 1, L square t power minus.
Minus 3.
-3.
This is for power. Hope you are following, children. How to, if you know the formula, you can derive the dimension. That's all. Any formula, see, any physical quantity, if you are asked to find out the, give the dimension, if you know the formula, from that formula, you can easily give the dimension. Okay, let me ask you one thing. Very simple. Universal gravitational constant, I think you know. You know?
Yes, ma'am.
What is that? G.
F is equal.
Capital G, correct? Yeah? So, how to, I think you know from Newton's law of gravitation, F is equal to G, M1, M2 by R squared, na? Aata hai?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
From that, what is G therefore? G is equal to FR squared divided by M1, M2 ना formula है ना? इधर से आपको G is equal to FR squared by M1, M2, whether it is clear? Therefore, from that you have to, so from this you have to give the dimension. You know the formula for G. Okay, from that what is the dimension? Force. What is force? Yeah.
MLT minus 2.
T power minus 2. Okay, into R squared, L squared divided by M1, M2. Both are mass only. M1, mass of one body,
Mass square.
M squared. Okay, got it? Therefore, now you tell me this M and this M will go. Therefore, M power minus 1 हो जाएगा ना? इसमें तो M power, ये तो M power 1 है. Okay. Therefore, M power minus 1, L1, L squared, therefore L cube. Are you following? Then T power minus 2. T power minus 2. Are you following? M power minus 1, L cube, T power minus 2. Hope you are following, children.
Yes, ma'am.
So, okay, just next one. Let me give you one more. I'll give you, can you calculate and tell me who will give me, I will randomly, I will ask, okay? Surface tension. I will give you the formula, okay, because you know, don't know, we'll be studying 11th standard only, surface tension. Surface tension formula is nothing but, surface tension is nothing but force per unit length. Force per unit length. Can you give me now what is the dimension?
Yes, ma'am.
What is for force? Tell me. Mohan is here. Mohan? Mohan is
Yes,
here.
ma'am. Yes, ma'am.
Tell me.
Ma'am, M1, L minus 1, T minus 2.
How do you, first to force you tell me. F. M.
M1,
Ah.
L minus 1,
Why L minus? Force के लिए.
ma'am.
What?
M1, L1, T minus 2, ma'am, by L square, ma'am.
Wait. Oh, for length L squared for you. M L T power minus 2. Okay, that is for force.
Yes,
For
ma'am.
length L squared.
L, ma'am.
How do you say L squared then? Okay, both will cancel, na? L will cancel.
Yes, ma'am.
Therefore, M power 1, T power minus 2. That's it. Are you following? This is for surface tension. Okay. Are you following, children? That is
Yes,
L,
ma'am.
which means that, what is L power? 0. L power 0 is 1. That's it. Okay. Shall we go for the next one? I think you have idea now. You have idea.
Yes, ma'am.
And let me give you what is the unit for, what is the dimension for angle? Very important here, you see. Angle. Angle means, see, theta, I think if I want to give you angle, no, see, arc, correct? Theta. This is R, this is L. What is theta? Is equal to R by L now if I give. Are you following, children?
Yes, ma'am.
Ma'am.
Yes,
Yes,
ma'am.
ma'am.
R by L, I think this you know, we have seen arc. Okay, R by L. Therefore, dimension for R is, what is dimension
Ma'am,
for
no
R?
dimension.
Why? Because dimension for R is L and for length also L. Therefore, it doesn't have dimension. So, what is the dimension here? M power 0, L power 0, T power 0. Dimensionless. Angle doesn't have dimension, but it has unit radian. Unit is radian. Are you following, children? Is it clear? Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now let me give you angular velocity. What is angular velocity? Omega.
Angle by time.
This theta by time. Angle. Theta by time. Angle swept per unit time is omega. That is angular velocity. Therefore, what should be the unit? Theta is, what is the dimension? Theta ka the dimension here. Therefore, what is the dimension for omega? 1
T
by 2.
minus 1.
T power minus 1. Are you following, children? That's it. Very simple. You know M power 0, L power 0, T power minus 1. Got it? Okay. Okay.
Yes, ma'am.
One more, let me see. Moment of inertia. Because you have studied no, in the moment of inertia. What is moment of inertia? It is the inertia for inertia of a body which is rotating body. Moment of inertia, I think we have seen now. Where we have seen moment of inertia? Can you recall? What is the
angular momentum?
Yeah, I, capital I.
Angular momentum.
Yeah, capital I. Angular momentum. Conservation of angular momentum. Okay, therefore we have seen moment of inertia. It is nothing but inertia of a rotating body. Okay, therefore now moment of inertia, formula for moment of inertia I'll give you. From that you give me. Okay, mr squared. Okay, therefore tell me.
M1 L
M
square
L square.
T0.
That's it. M1 L square T over 0. This is moment of inertia. Are you following? Is it clear?
Yes, ma'am.
From this, I think you can very well. Angular acceleration क्या होता है? Angular alpha na? Alpha is nothing but change in angular velocity, rate of change of angular velocity. That is, I told you, omega 2 minus
Delta omega by T.
time. Delta omega. Therefore, omega 2 minus omega 2 is a final angular velocity. This is initial angular velocity. V minus u by t. Like that, omega 2 minus omega 1 by t. Okay. Therefore, what is the dimension? What is
T
for omega?
minus 2.
Yeah. Therefore, it is for this one, it is t power minus 1, m power 0, L power 0, t power minus divided by t. Therefore, it is m power 0, L power 0, t power minus 2. Hope you are following, children. That's it. Okay. With this. Okay, because you are torque. Okay. Let me complete. Torque. Formula क्या होता है torque का?
Force into perpendicular distance.
Force into
Perpendicular.
Yeah, okay. But I think I told you F is equal to ma. From that, I think I told you, no, the role played by mass is played by torque. I think I told you in this one. Force into perpendicular distances, torque is fine. But I have not taught you so far that concept. But
Moment of inertia into average angular acceleration.
I alpha, correct? So whatever we know from that, we will see. I into alpha, I is, what is that? M power 1, L square, t power 0. Into alpha, just now we have seen t power minus 2 na. Okay, therefore, can you give me what is for torque? Therefore, m power 1. Okay, L squared, t power minus 2. And that is, I think Hitesh just now told what is the F into perpendicular distance. Na? F into R, perpendicular distance. F is m L T power minus 2. R is L. Therefore, m L square T power minus 2. Therefore, I think you know, now you can torque. Okay, listen, torque. And energy, potential energy, kinetic energy, work done, everything are all having same dimension, na? Hannah?
Yes, ma'am.
M L square T power minus 2 is nothing but dimension for work done, dimension for energy. That is one of the very, very, very big limitation of dimension. Why? Torque and energy are completely separate. They are different physical quantity. Work done, energy and torque, they are completely different physical quantities. But their dimensions are same, na? So if
Yes,
you
ma'am.
if you are given, give the dimension, dimension is given, give the physical quantity, okay, of the physical, see, from the dimension, if you are asked to give the physical quantity, you may get confused whether it is torque, what they mean, whether it is torque, whether it is energy or work done, okay, you don't know. That is a very important limitation of what is that dimension analysis, dimension method. Okay, hope, I think, shall we, I think whether the what the concept is clear. If any physical quantity is given, can you find out the dimension for it now, children?
Yes, ma'am.
Ma'am,
Yes, ma'am.
Yeah.
Ma'am.
Yeah, tell me.
ma'am, can we take this for electrical quantities?
Velocity gradient. You can. Okay. So, wait, velocity gradient. What is velocity gradient? That is why now we are dealing with mechanics, you know. Okay. That is why I don't want you, everything, we will see everything in detail in 12th standard. Okay. Anyhow, if you want, we will see any one or two. Okay. Right. Velocity gradient means change in velocity per unit length. Velocity formula, change in gradient of any physical quantity is nothing but rate of change of physical quantity means change in physical quantity divided by time, na? Rate of change of velocity, v minus u by t. Like that, that is not, okay, that is nothing but change in physical quantity with respect to time. Change in physical quantity with respect to length, distance means it is gradient. Okay, velocity gradient. The pressure gradient, like that. So, V by L. Therefore, how to do? L T power minus 1 is for क्या है? Tell me. This
B
is
minus.
L T power minus 1 is for V, na? Velocity, na? M power 0. Okay, divided by length. Therefore, T power minus 1. Are you following? Therefore, it is nothing but M power 0, L power 0, T power minus 1. Velocity gradient. Okay. Now, because you want it, let me go for charge. How to give the dimension for charge, electricity. Okay, with that one, I will give you easy, but next year we will see. Anyhow, charge. What is charge? Charge is nothing but time is Q by T. Our charge is equal to I into T, na? Charge is equal to current into time. Correct? Therefore, current. Therefore, it is current is what is dimension for current?
Ampere.
Huh? Yeah. I think first I started with that one. No, it is current is nothing but base, fundamental unit, dimension. A. I think I told you. I have given na. A.
Yes, ma'am.
And T only. Time is T. Therefore, which means that it is independent of mass, it is independent of length, but depends on dimension minus 1 times the dimension of A and plus 1 times the dimension of time. Hope you are following now. Are you following?
Yes, ma'am.
Yes, ma'am.
Yeah. Therefore, okay, potential difference. electric potential difference? Tell me. Electric potential difference. Can you define potential difference between any 2 points? There's nothing but work done in moving a unit charge from one point to another. Last year, whether you have studied W by Q. Studied or not, yeah?
Yes, ma'am.
इसका apply करो. Therefore, what is work done? Work done is, after all, M. L power
MLT minus 2.
T power minus 2. Correct? Therefore, divided by charge, just now we have seen A power minus 1, T power 1. Correct? Okay. Therefore, what is the dimension for potential difference? Tell me. M. M power 1. L squared. Okay. A power 1, because A comes there. A, you will keep A afterwards because it is electricity. First mechanics, everything. T power
Minus 1.
minus T power
Minus 1.
Minus 1.
T power minus 1 na?
Ma'am, minus 3, ma'am.
T power 1 ऊपर जा रहे T power minus 1
minus
Minus 3, ma'am.
Minus 3, ma'am.
T power minus 3 ma'am. And A.
A power 1, ma'am.
A power
1,
A
ma'am.
power 1.
yeah. Something is wrong here. I think I did some mistake. Blunder here I have done. What is that? You tell me. A
should be 1.
Why didn't you tell me?
A power 1.
Yeah, why didn't you tell me? Just now I realized I'm saying that only. Huh? See, that is why on seeing this one I have a doubt. A power 1 na?
Yes, ma'am.
A T only. You should tell me immediately, na? Which means that you are not in the class. Then I can say, madam, this is a see A के लिए तो A power minus 1 मैंने डाला ना? See, children, you have to be alert. Okay, sometimes see the teachers, there may be slip. It is not that see A T I have done. I don't know how minus 1 I मैंने डाला. Anyhow, so now you tell me it is क्या है यार? This is equal to T power minus and
A power minus
A power minus 1.
Thank God I have seen. You people are not. I'm not happy. Immediately you should have told. How, madam? Okay, right. Therefore, I think you know now. M power 1, L squared, T power minus 3, A power minus 1. Okay. Okay. Now I will give you some time. Resistance के लिए करो. Resistance. What is the formula for resistance?
Potential difference.
Potential
I-
by current.
V by I. What is V? Just now we have seen. Tell me, how are you doing?
M
T power
M0
power 1,
L2
T
T minus
M power
L
1,
power
L power 2,
2, T
T
power
minus
minus
3,
3,
A power
A power
minus
minus 1.
1.
A power minus 1 na?
Minus
2 ma'am, minus 2.
minus 2.
A power minus 2.
That is why I am waiting. See, M power A. Here A power 1 na? A power 1 ऊपर आने से A power minus 1 it will become M power 1 L squared T power minus 3 A power minus 2. Got it? Got it?
Yes, ma'am.
Yes, ma'am.
That's